So good morning, good afternoon, and good evening. My name is Amy Savage, and as most of you already know, I work in the Climate Change and Health Unit at WHO headquarters here in Geneva. I'm very pleased to welcome you to another one of our webinars in our series of webinars on climate change and health. Today, we're learning a little bit more about using quantitative approaches and modeling in a climate change and health vulnerability and adaptation assessment. Before we start, as always, we have a little bit of housekeeping. So we have two sessions of this webinar today. We have the one now at 9:30 Geneva time, so that we can cover a few time zones, and one this afternoon at 3 p.m. Geneva time. They do cover the same content, so if you're here now, no need to join the later session. The only difference is there will be different country experiences in the next session, but we are recording the webinars and putting all the materials and the recordings on the WHO website. So you're welcome to either join the later session or you can download the recordings and see the other country experiences. I'm sharing here the schedule of our upcoming webinars, which you're probably already familiar with. You'll see we're taking a break for summer in August, and then we'll be back in September with a webinar introducing our new upcoming guidance on integrating health in NDCs. And then we've got a couple more until the end of the year. So in this session, we do have interpretation in French and Arabic. So please see the instructions on this slide and set up your interpretation now if you'll be using it. Again, as always, we've set this up as a meeting rather than a webinar so that we can have some engagement and discussion, and particularly later we'll have a Q&A session. But there are quite a lot of people here, so I do ask you to please stay muted when you're not speaking, but feel free to use the chat and the Q&A functions throughout the session, and we'll aim to respond during the webinar if time permits, or we can respond later. So here you can see the agenda for our webinar this morning. In a moment, you'll hear from Dr. Diarmid Campbell-Lendrum, Head of the Climate Change and Health Unit at WHO, for some opening remarks and to set the foundation for the rest of the webinar. Then we'll have Dr. Adugna Woyessa Gemeda, who will provide an introduction to quantitative modeling in V&As. After that, we'll hear some experiences from Mozambique and Austria, how they've used quantitative methods of modeling in their vulnerability and adaptation assessments. And finally, as I said, we'll have the opportunity for some discussion and Q&A. So with that, I'm really pleased to hand over to Dr. Diarmid Campbell-Lendrum.
Thanks so much, Amy. It's, as always, a real pleasure to join these webinars, and I'm always impressed by the turnout, but also by the very nice program that's been put together by Amy and colleagues that was shown at the beginning of this webinar. And it is quite a comprehensive set of training instructions and interactive experiences with the country. So if you're just joining for this webinar, we would like again to refer you to the rest of the program, to the recordings and the information that's been shared there. And my role today is basically just to say a few words of introduction, including putting this particular webinar in context. And as I do that, let me just do the usual thing that we're all familiar now of trying to share the correct screen in order to share my slides. Can I just check that you can see my presentation now?
Yes,
brilliant. Okay, so as you saw in the introduction slides that Amy just presented, we have already done an introduction to the overall vulnerability and adaptation assessment process. And this slide, which you'll see again, I think, in a couple of minutes, is sort of the homework, the revision of what is involved in that process, in order to then orientate the discussion today around homing in on the quantitative aspects that are relevant to these V&A assessments. And as those of you who have worked in this field for a while will know that we have been supporting vulnerability and adaptation assessments for several years now. I think we published our first guidance in about 2010. So this process is is quite well practiced and has been applied in a lot of countries, and is just basically a logical process that has, in step one, describing the stages of planning the assessment, and then through steps 1 to 6, then looks at the current state of the problem, assesses the capacities of health relevant systems, health system, but other systems as well, then qualitatively and or quantitatively projects what climate change may do to those health risks and those systems as a basis for then identifying the intervention options that should be put into place, and then coming up with a synthesis of the overall problem and what we intend to do about it. And then for the context of this webinar, we're then homing in a little bit, if you like, on those steps which are for which quantitative assessment is most relevant. And they're relevant both for assessing what the current problem is. So it's obviously important to know how many cases of malaria, for example, you already have, or how many people are exposed to heat waves already in the current situation. But it's also particularly important for projecting forward what climate change may do to those risk factors and those capacities. So this is basically where we're pitching this webinar today within the overall V&A process. And I'll just give a couple of quick examples for orientation, and then you'll hear more in detail through the rest of the webinar. And I'm going straight to that step of projecting forward. And obviously, climate change is already affecting the current state of our climate and the health risks to which we're exposed. We're already seeing impacts around the world. But we're also, in the vulnerability and adaptation assessment, particularly looking at what the climate change to which we are already committed to, because we've already emitted a lot of greenhouse gases, and that we may be committed to even more if we continue to emit greenhouse gases, what that is likely to do to health exposures and the risks and eventually the impacts. And the first stage of that is just looking at what it may do to the hazards. And this is an example from work that we've supported over the last 10 years or so, putting together climate and health country profiles, of which the first thing we do is just to look at the projections of the hazards. So, for example, the likely increase in exposure to heat stress, so the percentage of days which would be above what we would currently consider to be a hazardous level, and the same for another hazard, in this case, increase in extreme rainfall. And as you can see, we already have enough information from climate science to project in a particular country which of those exposures which we're pretty certain are going to increase, heat stress being one of them, and others for which there's less certainty, but also still a significant probability that we may get increases in exposure. So, for example, increases in extreme rainfall. So this is an example of where we're using a quantitative approach in order to get some idea of what may go on in the future. The next step, which is described in that V&A process, is to project not just what may happen to the hazard, but what may also happen to the health impacts which we may experience. And we've done quite a lot of this now at WHO. In fact, one of the reasons I'm asked to make these opening remarks is that I was involved in leading the first quantitative assessment of the health impacts of climate change back in the year 2000, which we then updated in 2014 for forward projections. And at that time, we were able to make projections of the likely effects of different climate scenarios, from a medium or a high emission scenario, also taking into account other aspects of that affect health states. So what may happen to future development, because if development goes in a faster and more equitable way, if we lift more people out of poverty, provide better health services, then even with climate change, people will be better protected. And then comparing that to what would have happened if we had had no climate change, if we still had the stable climate that we had basically about 50 or 60 years ago. And at that time, we were able to make projections of what may happen to the burden of disease from several different climate-sensitive health impacts around the world, and including in different regions. So that's the kind of approach which we're encouraging countries to use. It can be done at the global level, it can be done at the regional level, or it can be done at the national or potentially even subnational level for certain hazards. So this is just to make clear the point that this is possible. This is something that has been done in the past and is increasingly being used for national climate and health vulnerability and adaptation assessments. The last thing I wanted to say before handing over to colleagues to give more detailed information on some of these techniques is to make clear that quantitative approaches are really important, but they're not the only thing that the only tool that we have at our disposal. And it's very important to put these in the context of other techniques, such as looking at scenarios of even qualitative scenarios of what may happen if we experience, for example, constant drought in sub-Saharan Africa. In that case, we don't have good quantitative models of what that may do to nutrition, malaria, diarrheal disease, and so on. But that doesn't mean that we shouldn't say anything about it. It's possible to look at projected scenarios. It's also possible to use expert judgment to fill in the gaps in cases where we may not have good quantitative models. So I think my final word on this is just to point out that quantitative approaches are very important, but we always need to put these in context, because in many cases we may not have the good data or the good models in order to look at other kinds of certain kinds of hazards. And in that case, we still need to say something about those hazards, rather than only restricting ourselves to a quantitative assessment for those hazards for which we have good data, because we may well end up missing the point. So with that, I'll hand back to Amy and look forward to the rest of the webinar. Thank you.
Thank you so much, Diarmid, for that really useful introduction and setting the scene for the rest of the webinar. Now I'm pleased to hand over to Dr. Adugna. Are you there? Who will provide an introduction to quantitative methods and approaches in V&As. Adugna?
Hello, good morning.
Hi, we can
good
hear you.
Good afternoon, good evening.
Would you like to share your screen?
Yes.
Perfect, we can see it. That's great.
Yeah, thank you very much. I'm very much delighted WHO invited me to present on this topic. I'm reminded of 2014 panel discussion held in Geneva. I was invited to present how climate is affecting malaria. So I'm very much delighted now WHO is inviting me to this webinar, and I'm very much benefited from interaction with my colleagues working for WHO in various institutions. So moving to, yeah, the slides are not moving.
No, not yet. Can you click on your slides and press forward?
Yeah, now it has moved, I think, yeah. I think this is summarized in the previous point. So the area we are going to focus in this presentation is as vulnerability assessment is a series, it follows a series of steps. It has 6 steps, and among those 6 steps, the part I'm going to present will be focusing on step 2 and step 4, the vulnerability assessment part that requires sensitivity analysis. Sensitivity is, I'm sorry, I think, yeah, the degree to which climate determines the occurrence and the spatial distribution of health outcomes. This is a tool. So the objective of sensitivity analysis are first to identify important factors. We know there are a lot of factors that are playing important role, but we have to identify which one are most important and exerting much of the influence. And sensitivity analysis also focuses on understanding the nature of the model or behavior of the model. That means it provides insights into how changes in specific variables affect the overall behavior of a model or system. That means it helps to reveal relationships and the dependencies that might not be apparent otherwise. The third one is enhancing decision-making. So decision-making always involves using some parameters to make prioritization or resource allocation. So for informed decision, we need evidence. So sensitivity analysis is playing an important role in guiding decision-making process, because we are investing, we are allocating resources, we are making prioritization. So we need evidence for that. In this instance, sensitivity analysis is a powerful tool for exploring and quantifying the relationship between outputs in models and systems. As we have benefited from the previous overview, quantitative approach is one of the important roles. We know there are changes going around, but we have to quantify and we have to avail that evidence for the users. The measurement of sensitivity analysis involves quantifying and assessing the impact of changes in the output. So what are the considerations for the analysis? First, are data available? Is it reliable? How is our data? How it is collected? How it is managed? We have to know about the quality of the data. Is that going to be available free of charge? What is the cost for that, for collecting, for compiling and processing it? Spatial and temporal resolution. Are we dealing with the data at district level, county level, or at what level are we going to compile the data? And the resolution, that means is that monthly, is that annual, seasonal? We have to know the nature of the data in terms of it is a time factor. Capacity to compare data. Can quantitative methods be used? Which one is preferable, qualitative or quantitative? We have to know this. Are there other resources available? Is expert consultation needed for the planning? So we have to have a team that is working on this. So we have to map the experts we have at local level or at national level, at regional level. So at the minimum, analysis of the relationship between health and average of core weather variables like temperature, precipitation, relative humidity, extreme weather event and pattern, they have to be explored. So what variables to consider? So data on seasonal and annual key climate hazards, maps of weather, we need those things. Where to find data? Is that national data from regional sources, information from national surveys, climate data? Yeah. So there are some concepts in sensitivity analysis. I don't want to go into detail, but for the benefit of the audience, I think these are some of the things we have to understand. And this is one of the examples that we can use when you say model. If you take flood inundation simulation, this is one of the input data, the model. Yeah, maybe one of important things that we have to understand about the questions that sensitivity analysis is expected to respond is, what input factors cause the largest variation in the output? We know there are a lot of factors are playing, and among those factors, we know which one is playing the largest role. Is there any factor whose variability has a negligible effect on the output? Are there interactions that amplify or dampen the variability induced by individual factors? So this is one of the important, these are the three questions that we have to ask ourselves. That means our sensitivity analysis has to give answer to. There are different types of sensitivity analysis, local and global sensitivity analysis, quantitative and qualitative, as you have already informed in the previous highlights, one at a time and all at a time, purposes or settings of sensitivity analysis. So these are the types of sensitivity analysis. Maybe we're not going to deal with those in detail, but we can understand how, in which aspect we are going to use them, and what are the benefits of each. How the questions are formulated and assessed. My slide is not moving. I'm sorry for that. Okay. The slide is not moving.
Maybe you could try unsharing and sharing again.
Okay, stop sharing and then, okay. I'm sorry for that. Okay. Our time is moving.
Okay.
The slide is not moving.
Would you like me to share the slides instead?
Okay, then I have to go to my email.
I have the copy of the slides. Would you like me to share instead?
Yes, you can do that.
Okay, just give me a moment.
I'm sorry for the glitch. I'm sorry.
I think it's okay. We'll these technical problems. Okay,
Yeah.
just let me know if you can see my screen now in presentation mode.
There are two slides.
Yes, we can.
Oh, you can?
Yes.
Okay, great. So this is the next slide. Just let me know when you want me to go forward.
Yeah, then can you put it on presentation mode?
It is in presentation mode.
Yeah, maybe on my computer. Yeah. Now it is okay.
Okay,
now I can use my computer. So
no,
yeah.
Okay, I think I have to do the slides.
Yeah. So three purposes or settings. If you take one of the types and see there is a ranking, screening, and mapping. So these are some of the details that the audience could explore more, how this type of sensitivity analysis is used. I think I'm successfully moving my slide. Thank you very much, Amy, for the support. Other types of sensitivity analysis settings are, there are set that are not included so far. The first one is the direction of the change. that is a plus or minus, increasing or decreasing, the presence of interactions between input factors, and sensitivity analysis and uncertainty analysis, sensitivity analysis and the model calibration, sensitivity analysis and the model diagnostics evaluation, dominant control analysis, robust decision making. So these are some of the things we have to understand when we are working the sensitivity analysis. We are not going to deal with those aspects of sensitivity analysis in detail, but this is just to give you overview on theoretical aspect. Related to visualization of the tools that we can use, taking global sensitivity analysis as example, we have to understand, we have to explore our data, and you can see the upper panel as to visualize input-output samples like scatter plots, colored scatter plots. So if you take the first one at the left side of the panel, you can see there is a scattered points in which it has low sensitivity. And if you take the right side one, emergence of pattern, that means there is a rising trend on x-axis after 0.6, and we can see this one is showing high sensitivity. So similarly, the lower panel is also showing similar things. Maybe for regression analysis also we can do the first one, the upper panel is showing empirical cumulative distribution function, and the lower one to visualize sensitivity indices, in which we are using bar plot, in which X3 and X5 have higher sensitivity. Quickly moving to the country case study for Ethiopia. Now I'm moving to the Ethiopian VA, which was done in 2014 and reported during 2015. So the objective was to, sorry, Amy, can you, okay.
So you should be, I think everyone can see my slides, which is on the objective.
Okay, yeah, very good. So the major objective was to assess yeah, it is overlapping with my slides and I'm moving it to one of the corners. Yeah, to assess the vulnerability of population and the health system to Ethiopia, impacts of climate-related risks and weather variability, and then to develop appropriate national health adaptation strategy. There are about 5 specific objectives. I took the first 2 as an example for this presentation: to define level and the distribution of vulnerability, determine the association between climate and climate change and the priority health issues. Okay, now I'm facing the same problem, and I can use your, yeah. These slides are maybe the table. I think the table is displayed for the audience. The tables are showing some, okay. Yeah, the tables, from the tables you can see how we have data from health determinants like climate, natural capital, financial capital, physical capital, and human capital. So these are categorized into 9 profiles, and then we have indicators, and we have unit of measurement for each of them. If you take, for example, climate, we have climate change in temperature, climate change in precipitation, and we collected all those data from various institutions. Next slide. Yeah, so when we come to the data types and sources, health data and information was collected from health and health-related indicators from the Ministry of Health. So Ministry of Health is publishing this document every year, and a lot of information is obtained from the health and the health-related indicators document. So these are the data. We have also used a fresh survey. By that time, it was provision assessment plus survey. And coming to the climate data and information, we collected monthly temperature and rainfall, relative humidity data from Ethiopian Meteorological Institute, the previous National Meteorological Agency of Ethiopia, the population data from Ethiopian Statistics Service, previously known as Central Statistics Agency. Next slide. Yeah, maybe when we decided to use the secondary data because there was a resource constraint. We couldn't go and collect fresh data using survey, and we decided where a team of experts coming from Public Health Institute, from academia, and from WHO. So, sorry. And we decided to use secondary data. So this secondary data is available at some national level. We had 11 regions, 9 regions by that time, and 2 city administrations, and we use aggregated data. We don't have data at below region. So if you take some of the regions, they are covering 1/3 of the country, and they are diverse. And even we had some questions coming from the decision makers that how this is going to be informative enough. So this is one of the setbacks of the data we have used. Sometimes we're challenged by the quality of the data, like missing data. Next slide. So the data management was handled by experts who joined us from academia and who was expert in GIS and biostatistics, and he did the data cleaning and did some percentage, and we had the descriptive statistics. Next slide. So we did some statistical analysis like generalized linear model. So the descriptive analysis we used for temperature, rainfall, for the minimum and the maximum is a box plot to understand our data, to identify outliers, and how our data is, how it looks like. Next slide. The other thing is for it was presented earlier. Some of the things like the drought issues from 1965 to 2010, we collected data from various sources, and we tried to see the population affected. And we have also the prevalence of diarrhea and sanitation coverage, and the mean for the national level, and presented for the sub-national. Next slide. We have also used regression analysis. From regression analysis, what you expect is which factors are most important, which factors we can ignore because of their contribution, how these factors interact. That means whether each independent variable is interacting or not. And perhaps most important, how certain are we about all these factors? So we have dependent variable and dependent variables. Our dependent variable was the main factors that we are trying to understand, mainly the health outcome, and independent variables are the factors that you were trying to explore, like climate factors and others. Next slide. Yeah, so some of our findings to give you some overview about maybe what is the relationship between diarrhea and rainfall. We have seen that about 7.6% and 6.3% decline of diarrhea for every 1 millimeter of rainfall in one of the regions and the city administration. They are especially Afar is arid and semi-arid. Genito is also a city administration, which is ecologically in a semi-arid area, in which water is one of the challenges for the area. Perhaps the amount of water at household level in Afar and Eduardo might have been a factor for increasing trend of diarrhea because of shortage of water. Yeah, can we move to next slide? Yeah, quickly moving to the health vulnerability index. As we have seen in the previous table, in which we have 9 profiles, all those, they are categorized into 3. The first one is exposure, sensitivity, adaptive capacity. So we calculated exposure and the average for each region, and then we combined to develop health vulnerability index using a model. Next slide. Using a tool which was used by Human Development Index that was used for calculating life expectancy. So I don't want to go to the details how this was done, but there is a formula in which you are going to insert in HV and IPCC formula, and then you compute vulnerability index for each region, and that you can use for your national adaptation plan. Next slide. Yeah, so this vulnerability index helped us to categorize the country into 4. The first category is least vulnerable to climate sensitive disease. You can see the regions, and it covers only less than 1% of the geographical area. And about 50% of the country was highly, moderately vulnerable. And highly vulnerable one is one region. It is covering 10 to 11%. And highly vulnerable ones are regions, in fact, which are located in, these are the regions which are maybe varying strongly from other regions. Next slide. So this is the map that we have generated, and this is the map that was used for communicating the decision makers. And really, this was the time when we had a big debate among regional health bureau representatives, in which the time we generated this data was El Nino year, and at that time there are spots, hotspot areas where high droughts and socio-economic challenges were there, and people were asking why this data didn't capture the current situation, why it is not reflecting exactly what is happening on the ground. So this was one of the challenges. As I've already mentioned, we have used aggregated data, and this aggregated data it is highly likely masking the local situation, like district level and below district administrative units in reflecting everything. Next slide, please. Yeah, now we have covered the vulnerability assessment part, in which our output was health vulnerability index, and we are moving to the future risk assessment part. This is well presented by a previous senior expert. So I'm very much delighted this is well covered. And this area is to describe how current health risks could change under diverse scenarios of climate change and development. It estimates the possible additional burden of adverse health outcomes due to climate change. We know that climate change is playing a certain portion of the health outcomes, and we have to understand that. So this in the first one is the pathways of greenhouse emissions and the level of emission at each country or at each territory, development pathways of mitigation policies, the status of the country in implementing the mitigation policies. So projections of health risks generally rely on the combination of greenhouse gas emissions and the development pathways. So this is one of the high-level things that we have to be familiar with when we are doing the projection. So maybe moving to some theoretical aspects of future health risks of climate change, that means the time series analysis. It is one of the things that is very important to analyze a sequence of data points collected over regular time interval and to consider time as independent variable, whether it is monthly, seasonal, or annual, or below that. This is considering time as one of independent variable. So its aim is to identify trends across a long period of time, seasonal patterns, and other underlying structures that make forecasts and informed decision based on temporal data. Its significance is that it is analyzing the historical data set and its patterns, and it helps us understanding and matching the current situation with patterns derived from the previous stage. And it also helps us understanding the factor or factors influencing certain variables in different periods. Next slide. Still, it has some limitations. Similar to other models, it has a problem with missing data. It doesn't consider if there is a missing data. And other thing is we are expected to transform and we have to smooth the data. Next slide. Yeah, this one is maybe to show you how forecasting the potential effects of climate change on malaria in the Lake Victoria Basin using regionalized climate projections. So we can see for different scenarios and models, we can see how malaria cases among 5 years old and above projected for Muleba Hospital in Tanzania for the period of 2006 and 21 to 2100. So understanding this, taking the different models for this period, using these 3 scenarios, we can use the different models to show how climate is affected by malaria is affected by climate change. Yeah, I think this is last slide. Thank you very much. I think I have saved 5 minutes. Thank you.
Thanks so much, Adugna, for that detailed presentation. I'm now really pleased to introduce Professor Genito Maure, who will be talking about the really exceptional work that they're doing in Mozambique. So Genito.
Bon dia, good morning, bonjour. Again, I'm Genito Maure from the Eduardo University, but I work in very close collaboration with the Ministry of Health and the National Institute of Health of Mozambique, as I'm a member of the technical working group on on climate and health. So again, thank you very much for inviting me to present on this webinar. So I'll try to build on the slides that were already presented by my colleague from Ethiopia. As far as I noticed, there are a lot of commonalities. In fact, the work that we have done in Mozambique learned a lot from the work that was conducted in Ethiopia. So yeah, let me see if I can. Okay. So this is well known. This is the location of Mozambique in southern western basin of the Indian Ocean. It's very prone to tropical cyclones. We are also lying on the downriver of the 9 major basins in southern Africa. So whenever it rains, regardless if it rains on the country, we will always suffer from the effects of flooding and so on and so forth. The burden of disease in the country is highly dominated by climate-sensitive diseases such as malaria and diarrhea. We also have indication from the climate projection that we are going to experience increase in temperatures, delays on onset of the rainy season. Especially, you may know that the agriculture sector is one of the pillars, in the country, that has, of course, effects on nutrition and so on and so forth. Since the country has adhered to important international commitments, we have planned also to produce the HNAP, the National Adaptation Plan for the health sector. And we needed to do some work, how to conduct that. So, Amy, now, okay, I'll just use my arrows. So the objective of this was of the work that we have conducted was to assess the vulnerability and adaptation needs of the health sector, so as to provide what we would call a scientific baseline for the development of HNAP. So we wanted to have a sustainable methodology using an objective method, a quantitative methodology, which is based on the commonly agreed, widely agreed methodology that was developed by the WHO, which introduces the concept of health vulnerability index. We also wanted to identify geographical areas that were most vulnerable, just like the Ethiopian case. We also wanted to conduct a qualitative assessment of the impact of climate change due to the limitations of the data availability on the surveillance side. We wanted to work with dengue and chikungunya, but due to surveillance, that's why I'm putting it in brackets, because this is an ongoing process. It's quite limited again. And finally, propose recommendations, and also identify research needs and information gaps. So, as I said, this used the same methodology that was presented by the previous speaker. It uses what we call the Health Vulnerability Index, and for the first time in the country, we did this for all the 162 districts of Mozambique. I mean, the health sector was previously somehow neglected in terms of the climate impacts in it, because previous studies in the country have shown that the ranking that it was occupying has the impacted sector was very low, which means we didn't have a proper knowledge of what was going on. So yeah, we did this at the district level. That was the first time that we managed to map the country. I mean, produce a health vulnerability index for each of the districts. So this has also been presented. So the index is defined according to the IPCC 2007 publication. It takes into account three variables: the exposure, the adaptive capacity, and the sensitivity. Here is the formula that is used. So we had to map exposure, adaptive capacity, and sensitivity for each of the districts that we have in the country. So again, the methodology is still the same. This is the very same table that was presented by the previous speaker. For exposure, we look at climate variables. For sensitivity, we look at other elements like geography, ecosystem risk, and so on. We also look at the demographics, and also included aspects of vulnerable population. We may want to say, okay, we may want to add like other elements that are now in the Disaster Reduction Act in Mozambique that includes internally displaced people that are further impacted by climate change. So this aspect could also be put in here, but at the time that we conducted this information was not available. We also had the proportion of vulnerable population due to health conditions. We had financial resources for the adaptive capacity, access to health service, human resources that are working on the health sector, the water and sanitation, and social determinants of health. So moving forward, doing all this calculation, we generated, of course, a multi-column table with indicators for exposure, for sensitivity, and adaptive capacity. And for each of the districts, we calculated the corresponding indices, like the exposure indices, index for sensitivity, and the index for adaptive capacity. These are the variables that are part of the formula that I just showed you. So what I would say here is the darker the shade of the red. Excuse me. Okay, the darker the shade of the red, the more exposed in this case the country is, the more sensitive the country is in this middle map, and the more or the less adaptive capacity the country or the district has. So you can look at this one. This is the one that shows how the capacity of the country is low. It's generally low. I mean, if you look at the whole country, we have 84% of the territory, around 66% of the population with low to very low adaptive capacity. And we also notice that there is a high inequality between urban and rural areas. And the indicator, since we have a column with multiple indicators, the indicator that was the forcing of the low adaptive capacity was the WASH sector, and related especially to access to health service components and water. So clean water. So if we put those maps in the formula, we end up with this map, which is the health vulnerability index, where we have high to very high vulnerability index in 42 districts, which corresponds to 32% of the territory and 24% of the population. And we have 8 districts with extremely high or very high health vulnerability index, which are these ones with the dark red or brown. If you I don't know how you're seeing the colors on your side. So one interesting aspect is that 15 of the 20 least vulnerable districts are urban. So again, to show that there is an equality in terms of urban and rural settings. So in conclusion, we would say that exposure, we have the southern region of the country that is simultaneously exposed to three events, namely cyclones, droughts, and floods. We have a high to very high sensitivity in 12 of the districts. I'm not going to name the cities because most of you are not probably aware of where they are located, but these are the most populated, these are the largest cities in the country. We have a generalized low to very low adaptive capacity in the country. And again, as I said, out of the 5 adaptive index components, the WASH element had the worst performance. So that means we can directly address the WASH and look at what variables are involved and try to address those in order to create or increase adaptive capacity. I will quickly jump into conclusions. I'm sorry for saying so, but I have some additional maps that I wanted to share with you. What I would say is that we have an objective and scientific baseline for the development of national adaptation plan. So in fact, this adaptation plan is being now drafted using the work that was done on the vulnerability. In terms of methodology, this has been already mentioned by the previous speaker. If we don't have the data, we have poor coverage of data, or we have lack of systematic recording, or the data that is relevant for our work is lying on a different organization, and there is limited flexibility in sharing sectoral data, then there's a big problem for generating this kind of products using this methodology. Probably I'm not going to say a lot out here, but what I would say is that we have been able to develop a contingency plan for the health sector because we have the seasonal forecast for the coming rain season, for example, starting in October to March. If we have the forecast, since we know the relationship between the variables, and in a short term, we know that the socioeconomic and other indicators will not change that much. At least we are able to predict where where to allocate the resources. There are other recommendations related to the mapping of health infrastructure according to the type of risks. This is a work that we have already done, and it's being concluded at this stage because we already have the maps of the events and the extreme events and so on. All we need to do was to put the health infrastructure map on top of it so that we can know which infrastructure, what type of infrastructure is exposed to which kind of risk. We're also in the process of integrating surveillance with climate. This is an ongoing work. It's a bit slow, but it's ongoing. We have the engagement of the relevant organizations. We also need to standardize the platform for data collection and also strengthen the surveillance. I wanted to show you work that we are conducting now. It's going to be published soon, hopefully. This is an artificial intelligence based work because we have so many variables. Variables are just adding to the columns that I just mentioned. So we try to see what would be the elements. We will try to check sensitivity here. So we are using an AI algorithm called random forest. I can give you details sometime later. But for the most affected province in the country, so we are seeing that the AI has got the ability to mimic at least observed patterns if we are using the predictors that we are taking into account. And one more very important aspect is to notice that depending on the location, the predictor is location specific. So in some cases, we will have mean temperature being the most important variable. In some other places, we will have the mean, the relative humidity, and so on and so forth. So you can see the differences here in this map. So it's important to use these kind of tools so that if we have the forecasts, I mean, of let's say the temperature and the relative humidity and so on, all these climate variables for the future, we can specify which variable is important for a specific place within the country, for this specific district. So which makes our work somehow more robust in terms of accuracy and confidence. This is just some epidemiological positive predictive value, sensitivity, false alarm ratio, and accuracy. These variables were extracted by a work that is being supported by WHO on early warning systems, but we wanted to see how our AI-based model could also replicate those, and we have a very good results now to share. There are some additional work that is being done on heat waves. Diarmid mentioned the role of the heat waves at the beginning. So this is a work that we also published recently, and also for precipitation change and so on, so that we can feed this information into the future for the future risk assessment. So if you want more details, we have a publication on assessing vulnerability and adaptation needs of Mozambique. This is a comprehensive study and is available free of charge online. So yeah, over. That's what I would share with you for now. Over. Thank you.
Thanks so much, Genito. That was really interesting. It's good. It's interesting to see all the impressive work that's happening in Mozambique and learn about some of those novel approaches related to AI. I can see there's already a lot of questions in the chat for you, so maybe we'll be able to get to some of those in the discussion section as well. But for now, I'm really pleased to invite Ilonka Horváth, who is a senior health expert at the Competence Center for Climate and Health Austria, to share some experiences of using quantitative methods in the V&A in Austria.
It should work now.
Yes,
is it?
perfect.
Okay,
Yeah.
thank you. Okay. Well, thank you for the invitation. I'm happy to share some country experiences from Austria, and in particular on the vulnerability assessment, on the quantitative approach we are using here. I just want to start with the contextualization. Because and also to give an overview on the big picture, we were using the climate change and health vulnerability and adaptation assessment from WHO, which was published in 2021, and we used this framework as a baseline for developing something similar, something very practical, which can be used in the national context in Austria, and we called it, which is like we call our methodology Climate Resilience Check Health 2050. And in fact, we are providing it for Austrian regions as well as for Austrian municipalities. Our Climate Resilience Check Health aims to systematically address the interface of climate change and health, reach out to local communities and also to experts of experience. And we are aiming to increase the adaptive capacities and also to sustain future health on the regional level. So this also as an overview, this is the standardized and comparable process we created. As I already mentioned, it is based on the WHO framework. What we changed somehow is that we are using a mixed method approach. We are using three main components. On the one hand, we have a data-driven assessment process. We then use the results from this data analysis to start a participatory assessment process with local communities. And the third component is a desktop research in regard to the adaptation assessment. And I today would really focus on the vulnerability assessment, which is highlighted in my graph here. So I think I don't have to explain too much on the WHO framework. Just a reminder, because I will base my presentation on this graph. We are using, so we have like in the vulnerability assessment, we have these 5 dimensions of vulnerabilities, which we are also using. So within our Austrian methodology and also the vulnerability assessment we are conducting, we are aiming to calculate quantitative values for each of the factors and indicators in relation to the population or geographical area. We are aiming to calculate the Austrian average as a baseline for comparison of the region. We are aiming to create values for the region as deviation from the national average. And we are also aiming to create visualization. And I just would like to give you more details on these results. So the first challenge actually we were facing was to find spatial references for the data analysis. So the graph you see here is Austria, so that's the shape of Austria. And most of the health data the health data actually is available in the entity of like the healthcare regions, which you see outlined with outlines. We have to go back to this, we have to use this quite big scale for our data, and it's not possible to make it in smaller scales, like geographic scales. The second challenge we were facing, so technically in regard of the data mapping, we had to do 3 steps. The first step was for each of the vulnerability dimension, we had to describe various vulnerability factors, and then in the next step, there's the need to identify indicators to describe each of the factors. Practically, what happened was in the first step, we had to do a validation of the applicability of the suggested vulnerability factor. So for example, for the dimension of for the social political vulnerability factors, we realized that they are not fully applicable for Austria. For example, the one listed in the WHO framework, like freedom of speech or political instability, is not that much applicable for Austria, as Austria is a very strong democracy. So we had to find and define other factors which describes social political vulnerability factors in Austria. We decided, for example, to go on social cohesion, and also, for example, on the percentage of people eligible to vote. The second practical step was that we had to define for each of the factor we decided on, we had to identify suitable indicators that also represents the specific vulnerability factor. And So factors like social cohesion, for example, are hard to measure directly because we don't have any data for it. So what we did then, we kind of created, or we were looking for proxy indicators. And just to give you an example, for the social cohesion, we used the density of association as a proxy indicator, or for example, for the eligibility to vote, we used the amount of like the percentage of non-Austrian citizenship. Citizenships within the population in this region. Because there we had, this is data which is available and can be used. And the third step was that we also had to look if the data is also, the data of like the indicator is also available on the small geographic scale, meaning on the regional level. So at the end, we had, in fact, a reduced set of factors based on the availability of the indicators. And we extended the geographical factors by climatological factors, for example, the annual number of heat days. So this is the adapted set of vulnerability factors we are using now for our vulnerability assessment in Austria. So this is, there's also what Genito said before, there's also a lot of limitations in it. As he outlined quite strongly before, and we also face the same problem, but this is what we kind of created, and this is what we can produce for each region in Austria. In total, we are still keeping the 5 dimensions from the WHO framework. We are having 23 vulnerabilities factors within these 5 dimensions. And these factors are described by 25 indicators in total. In fact, we are using 11 different data sources which are available on national level. To give you an idea of the visualization, we can visualize each indicator or each factor as in a geographical map. Again, the Austrian shape. This is looking at the proportion of over 65-year-olds, and the darker the color comes, the bigger, the higher is the percentage of over 65-year-olds. And the second visualization looks on the regional vulnerability. And I just give I'm really sorry that we don't have this graph in English, so I just want to give you some ideas what it really tells us. So this circular bar plot, on the one hand, in the colors describe the vulnerability dimensions, and then each column describes a factor. And for example, in the yellow slide, you see the over 65-year-olds. We have, like, for example, in the green section, which describes the socioeconomic factors, we have data on poverty, for example. And the blue columns describe the geographical and climatological factors. We have, for example, some data on risk of flooding, and the gray bars tells us about the biological factors as well as the health status. And I just give you an example on like one which is really highly, the region where I'm presenting here has a high vulnerability in terms of a lot of people are in need of care in this region, which also correlates with the age groups. Another thing I need to highlight in this graph is that there's a bold circle. I hope you clearly see it, but the bold circle gives us the Austrian average. So the conclusions, we realized that we have to acknowledge the complexity of vulnerabilities and also the health inequalities existing in this on this topic. We see challenges on 3 levels, on the applicability of the factors used and the derivation of suitable indicators, and of course the data availability on regional level. We need when creating this tool and also the methodology and the quantitative data-based analysis, we were really in need of a multidisciplinary team, the final conclusion is that we are really strongly believe that the future health status of the population will largely depend on how current adaptation strategies are successful in reducing the climate-sensitive health outcomes. So that's from my side. Thank you, Amy.
Thank you so much, Ilonka. It was really interesting to hear about a little bit more detail on the quantitative approaches within this very comprehensive V&A process that was undertaken by you and your team in Austria. Now, we have 9 minutes for discussion. There are already a lot of questions in the chat. Some have already been answered, some maybe need a little bit more elaboration. So I will invite Adugna to facilitate this discussion. Now I ask you to raise your hand. Everyone is able to unmute themselves. And when you ask your question, if you could just let us know if you're asking to one of the specific presenters, because we still have Genito and Ilonka here who hope they can answer some of your questions as well. So over to you, Adugna, and please just raise your hand if you would like to ask a question.
Thank you very much, Amy, for the opportunity. So I can't see hands. Maybe you can help me in identifying people who are raising their hand.
Sure, I can't see any hands either. I mean, we could start with one of the questions that's in the chat that was for Genito, where it was asked what formulas were used for calculation of index of exposure sensitivity or adaptive capacity. And Genito mentioned that he might be able to elaborate more during this session. So I don't know, Genito, if you have anything to add to the response that you already gave in the chat for this question.
Am I audible? Okay. So if you allow me, I just wanted to reshare a table that I had shared, and it was also shared by my colleague from Ethiopia. So basically, for the case of Mozambique, okay. So it's relating to the exposure. So what we looked at was changes in temperature, precipitation, relative humidity. And the years that we used were historical years from 1979 to 2016. We could use a different period for this, but these were the data that were made available by the National Institute of Meteorology. So we look at the changes and these variables for change in temperature, and we have put all these 3 indicators each on its own column. We have done the same for the number of extreme events during this period and so forth. But of course, these numbers will have different magnitudes. So we need to undergo a process of normalizing it. Normalizing was the formula that Adugna did not want to present, but it's sort of changing the scale from the original scale. For temperatures you have in degrees Celsius, but we are going to include temperature with number of extreme events, which is something with a different magnitude or different order of magnitude. So we need to put this in the same scale, let's say from -1 to 1, so that we can, using sensitivity studies, tests, we can see which of these variables affects the most, let's say, the exposure index. In this case, it's going to be this variable, this variable. We can use any statistical relationship. We can try to put means of these values, but we need to see which one is the most important to affect exposure. We do the same with sensitivity. These are the variables that we have chosen. There was an additional question in relation in whether we could bring non-communicable diseases into this. Yes, if you can, if you have the data, just put it in. Yeah, all you need to do is to see how sensitive is this, I mean, the sensitivity index, sorry for the repetition. Sensitivity index will change if there is a change of one of these indicators. So it's like putting weights in each of these indicators. I don't know if that answers the question.
Thank you very much. Any more question? I think all presenters are successful in meeting the need of the audience. So
I think there's one from David who's just raised his hand for Ilonka.
David.
Yeah, sure. So thank you, Ilonka, for that presentation. Very interesting. My question was about something you mentioned at the very beginning of your presentation, and that was who you're delivering your results to, which is, you mentioned regions and municipalities. And here in Norway, we see pretty big differences between the way municipalities are working with climate change adaptation. The larger municipalities have resources. Smaller municipalities are often struggling. So my question was, do you see those differences, and what can you do about that?
Thank you, David, for the question. Yes, indeed, actually, we were just, I just have to maybe also mention that we actually piloted our methodology last year, and we are kind of starting kind of a rollout at the moment, also trying to reach out for a larger number of regions and municipalities. In fact, it seems in Austria, at least, we have a strong network of climate change adaptation. It's called Climate Change Adaptation Network. It is financed by the Ministry of Climate, and they are more and more interested. So they are working on regional level. So they have a strong structure. They established already a strong structure on regional level. So in our experience at the moment is that they are looking more into health-related topics, which they didn't do that much in the last years. And for us, they are really interesting and very relevant cooperation partners. So it's not the municipality as such, but it is maybe sometimes organized by an association, which do have a network on several municipalities. And so we are working with this cooperation partner, with this network, regional network, and they're doing the regional work. What we are doing now, because we work for the National Public Health Institute, and in fact we are trying to reach out for also networks in terms of health promotion, for example, also to tell them, like to give them the idea that climate change, that our tool can also be needed by them. But there are in fact there are still a few steps to be made, but in fact, in particular, my vision is that I want really to decentralize the use of our methodology. It should not be only us being able to use it. Thank you.
Adugna, you're on mute. I don't know if you're speaking.
Thank you very much. I think we don't have hand, and I would like to hand to Amy. Thank you very much, Amy, for the support during my presentation. I hand over to you to make the final statement.
Thanks
Thank you
so much, Adugna. And we'll finish right on time, I think. I want to give a really, really, really huge thanks to all the presenters today. It was very interesting, but I also want to thank all of you for participating. It was very active engagement in the chat, in the discussion, and we hope you learned something. Just a quick reminder to have a look at the upcoming webinars that we have in the technical webinar series, and to let us know if there's any topics that we're not covering that you would like us to cover. And with that, I thank everyone, and I hope you all have a really great day. Bye-bye.